Hi, I'm Ken from Scotland. Welcome to my Week 5 video lesson for the sound production course at Coursera.org. In this lesson, I'll be demonstrating some of the effects that result from delaying a signal by different lengths of time, and I'll be doing these demonstrations using Logic Pro X. So let's get going. So in this first demonstration, I've got two identical copies of an audio recording of white noise. I've channeled them into an auxiliary channel and placed a plugin which has a nice spectrograph on it. Let's hear the two together. And you can see the spectrograph showing equal energy across all the frequencies. I've selected the second copy. I'm going up to choose samples, and a nudge of this white noise to the right, or basically a delay of one sample, I'll obtain by pressing the Alt key and the right hand arrow. And because it's set to samples, every time I nudge it, it'll move one sample, or give a delay of one sample. So you'll hear the original white noise and this identical copy but delayed by 1, 2 or 3 samples and so on. So let's see what goes on. There's the equal energy across the spectrum. There's one sample delay, and you can see the top ends come down a bit. 2 sample delay, and there appears a cut at maybe about 12k. Another 2 samples, now on 4 sample delay. That cut's moved down a bit. Now on 6 sample delay, and we're getting 2 cuts. Another 6, so we're now on 12 samples, and you can begin to see there's 18 samples now. You can begin to see what's called comb filtering. Next demonstration, I've got a car door shutting. Not a very musical sound. What I've done is put a delay in there. This is down here, and we're going to start the delay at 0.1 milliseconds, and there's 50% feedback on this, 50% dry, 50% wet sound that you're hearing. So let's hear it. Let's increase that delay. 0.2, 0.3, 0.4. Now continuing up, 2 milliseconds, 3 milliseconds, 5, 8 milliseconds. You can definitely hear a tone that's decreasing in frequency as we increase the delay time. And we reach, eventually, we're now up about 30 milliseconds, a state where we can hear the repeated sound quite clearly now. We're up at 40, 45 milliseconds. So that's an example of the brain interpreting very rapid short delays and repeats of them as a tone. Let's now move up the delay spectrum. I've got a fiddle track and put a plug-in stereo delay, left channel of 70 millisecond delay, right channel 80 millisecond delay. There's no feedback, 30% wet signal on both channels. Let's hear the fiddle now without the plug-in. And now putting the plug-in on, much more presence of a room and space there. Let's listen to it in the context of the mix, first without. And finally, a syncopated delay. I've got this syncopated to the tempo of 120 beats per minute for this project, and to single crotchet notes. So listen to the piano without the plugin, single chords, and now with the plugin. You can see that the delay is syncopated to the rhythm of the piece. Well, that's the end of this lesson, so thanks for watching the video, and I look forward to your feedback. Goodbye.